Our objective today is to apply t-test for one sample. So using this problem, our question is there a significant difference between the mean content of colas given to the pupils during the outreach activity and its label 8 ounce? So we can rewrite that as to compare the mean content of colas with the content claimed by the colas company if you want it to appear as objective and not as a problem. And then in answering this question, we are going to follow the hypothesis testing. So, number one step is to state the HO and HA. So, our null hypothesis is there is no significant difference between the mean content of colas given to the pupils during the outreach activity and its label, while the alternative is there is a significant difference between the mean content of colas given to the pupils during the outreach activity and its label. So these are example of two-tailed because we did not, of course, consider that one is higher or the other one is lower than the other. Initially, in setting for the level of significance, we will use 0.05 because this can be changed after generating the result if the p-value is less than 0.01. And then for step 3, we will also check if what is the possible test. So as written here, the possible test is one sample t-test or one sample Wilcoxon test. So let's go to our data to see what is the nature of our data. So this is now the content of colas of pupils 1 to pupil number given to pupil 1 until pupil number 15. The nature of our data is at least interval, or it is a numerical data, which means that it is possible to use parametric test. So in our previous video, we discussed that. And the next one, of course, we have to consider that our purpose is to compare one sample to population sample. One sample is the mean of the 15 contents of cola, and the population sample is the label in the 8 ounce cola. So the data is ratio and it is normally distributed, but we have to check that first. So to check it, we're going to use one sample KS. So we will use online calculator. So this is the online calculator for Kolmogorov-Smirnov test of normality. What we need to do is just to copy the contents or the data set here and paste it in the box. So we can use the shortcut Control V and then just click calculate. So it will provide you the value of mean, the median, standard deviation, and also skewness and kurtosis. So in our lesson in introduction, we also discussed that we have several ways of checking for the normality, and some of this is to compare the mean, median, and mode, and we can also consider the skewness and kurtosis. And then next, let us see what is the result. So the p-value is 0.22663, which means that the data does not differ significantly from which is normally distributed. So what we are trying to look at here is if the value is 0.5 and above, it means that the data is normally distributed. So this means that we can use t-test for one sample. So using the preliminary test like checking for the objective of the question to compare one sample to population mean, the nature of the data, it is ratio, and also for the normality. So no doubt we can say that the appropriate test for the data is one sample test. In case that we did not satisfy any of this, then we're going to use one sample Wilcoxon test. So let us also generate the result. So how to generate the result. So let's go back to our online calculator. So in this online calculator, we can find in the list the t-test for a single sample. So this is what we need. So we will click this. It will provide you with other information about the test, like the assumptions or the requirements, and also the null hypothesis and the equation. So let's click take me to the calculator, and let's copy our data set here. So the population mean is 8. So our population mean is 8. Our significance level initially is set to 0.05, and our hypothesis is two-tailed. Then click calculate. So this is now the result. The p-value is less than 0.05. So just in case that the p-value is less than 0.01, this is 0.037. It is above 0.01. So just in case that it is also below 0.01, you can also try to regenerate the result by just trying also 0.01. Then click calculate. So of course, if it's if the p-value is set, or the significance level rather is set into 0.01, the result is not significant. So let's bring it back to 0.05, which is the original set level of significance. And then go back to our hypothesis testing. So the t-test for one sample. So it's already copied here. So the generated result is the t-test value, negative 2.293397. So I just copied the initial analysis placed in or generated using the calculator. And then in addition to that, let us also compute for the degree of freedom. So the degree of freedom, the formula for this is n minus 1. This is very important if you are using the manual computation, because the table usually placed at the back of the book, wherein you have to consider what is the critical values that will be compared with the t-value here needs a value of degree of freedom. So let us just report that even if you're going to use online calculator. So for the degree of freedom for this example, because our data set is 15, so we have 2 to 16, or this is of course respondent 1 to, let us just place the number of our respondent. This is just respondent 1 to respondent 15. So our n is 15. Just deduct 1, that is your degree of freedom. So the degree of freedom is 14. So what is the decision? So as mentioned, we are going to compare it with our 0.05, though it's already indicated here that the result is significant, and it means that we need to reject the null hypothesis simply because 0.037778 is less than 0.05. So what is the meaning of that? It means that there is a significant difference between the mean content of colas given to the pupils during the outreach activities and its label 8 ohms. And step 6, the interpretation. So table 1, we can edit our table and present it in this manner. So table 1 displays the one sample t-test result on significant difference. So you can use this format and then just copy now the values generated in the calculator or online calculator. So let's go back to our online calculator. So remember that when we use the Kolmogorov-Smirnov test of normality, it gives us the value of the mean. It's 7.47, standard deviation 0.895 or 0.90, And then for the t-value, you can find for the t-value as reported in the generated result, it is negative 2.294 degree of freedom. So we computed for the value of degree of freedom. It is 14, p-value 0.038. So we round off to 3 decimal places. And then for the mean difference, you can just simply deduct 8 less 7.47 or 7.47 less 8. That's why it is a negative 0.53. So for its interpretation, so this is the interpretation. As gleaned in the Table 1, the mean content of colas given to the pupils during the outreach program was 7.47 ohms. This mean content was lower than the content label in the colas bottle. Moreover, the one sample test result shows that there was a significant difference between the sample mean content and the 8 ounce colas label. This indicates that the colas given to the pupils were significantly lower than 8 owns. This further means that the colas given did not pass the quality control of the colas company. Thus, the colas were donated instead of bringing back to the company. So for the first interpretation, as you observe here, we are comparing for the value of mean 7.47 and 8 ohms. And then support this by reporting now the inferential statistics results. So that is saying that there was a significant difference because that is the meaning of our t-value with its p-value. So we also reported that and give its implication that what is the indication of saying that there was a significant difference. So it means that it is significantly lower, and it also means that the given cola to the pupils did not pass the quality control. So you can give further information by also going back to the main reason why did you compare the mean of the 15 colas with the mean of what is in the bottle. So in the next video or in the next lesson, we are also going to consider other tests.